Hello friends, this video on NEET dual nature of radiation and matter is brought to you by examfear.com. No more fear from exam. Question number 18. A beam of white light is incident normally on a plane surface, absorbing 70% of the light and reflecting the rest. If the incident beam carries 10 watt of power, find the force exerted by it on the surface. Okay, so here two things are happening. So light is incident, some part is getting absorbed and some part is getting reflected. So now, there are two scenarios that is taking place here. Some part is getting absorbed and some part is getting reflected. So now let us first talk about the absorbed part. So if you talk about absorbed part, 70% of the light is getting absorbed. So 70% of 10 watts would be the power that is getting absorbed, right? Okay, so from this you can say this would be 0.7 into 10, right? Which is equal to 10. So which is equal to 10 watts basically. And what is 10 watts? What is 7 watts? 7 watts is basically 7 joules of energy per second. So this is basically 7 joules of energy per second. Now what is happening to the reflected part? So reflected part is 30% of 10 watts, right? Which is equal to 0.3 into 10, that is equal to 3 watts. So 3 watts would mean how much? It would mean 3 joules per second. So an energy of 3 joules per second. Now in this question we have to find out the force exerted on the surface. Now we know that force is equal to the rate of change of momentum. Right, so if we are able to find out momentum, then we can also find out the force, correct? Now, if you know that this relationship, that energy is equal to momentum into c, where c is the speed of light, right? So from this we can say that momentum is equal to E by c. Now, when you talk about change in momentum, so change in momentum for the absorbed part would be how much? E by c. So E for the absorbed part would be 7 joules, right? So the change in momentum for the absorbed part would be 7 by c. Now what would be the change in momentum for the reflected part? So the change now in the reflected part, what is happening? The light is falling like this, striking the surface and then getting reflected like this. So basically this is P1, this is P2. So the change in momentum, again the directions are also opposite. So the change in momentum would be 3 joules plus 3 joules divided by c. So in this case the change in momentum would be 3 by c plus 3 by c. So this is the change in momentum for the reflected part. So this is change in momentum for the reflected part, and this is the change in momentum for the absorbed part, because in the absorbed part nothing is getting reflected. So therefore the net change in momentum is 7 by c, correct? So now if you look at this, this is going to be 13 by c. Now c is 3 into 10 to the power 8 meter per second. So this comes out to be 4.3 into 10 to the power minus 8 newtons. So you see, this is a very conceptual problem, because most of the times children will make a mistake that they would not consider this 3 by c twice. So you need to understand that for absorption, what is happening? The light is just striking the surface and then it is never going back. But when you look at the reflected part, the light is falling, the light is incident, and then again it is getting reflected. So there is a net change in momentum, and if you find out the net change in momentum, then since both are in the opposite directions as well, so they sum up, correct? So in this fashion, for the reflected part and for the absorbed part, you need to separately find out the change in momentum, and the rate of change of momentum gives you the force. Question number 19. When a metal plate is exposed to a monochromatic beam of light of wavelength 400 nanometers, a negative potential of 1.1 volts is needed to stop the photocurrent. Find the threshold wavelength for the metal. Now negative potential of 1.1 volts is needed to stop the current. This shows that this is nothing but the value for stopping potential. So this is stopping potential and this is the frequency or this is the wavelength of the incident light. Correct? Now we have to find out the threshold wavelength, that is lambda naught. So let us quickly write the photoelectric equation, which is EV naught is equal to E minus phi. So EV naught is equal to HC by lambda minus HC by lambda naught. So therefore we can write it as HC by lambda naught is equal to HC by lambda minus EV naught. Or we can say 1 by lambda naught is equal to 1 by lambda minus EV naught divided by HC. So now all we need to do is just put the value. So lambda is given as 400 nanometers, which is 400 into 10 to the power minus 9. This minus E is 1.6 into 10 to the power minus 19 into V naught is equal to 1.1 volts divided by HC. H is 6.6 into 10 to the power minus 34. C is 3 into 10 to the power 8. So now when you calculate this, you get 0.162 into 10 to the power 7. So this is the value for 1 by lambda naught. So therefore lambda naught would be equal to 1 divided by 0.162 into 10 to the power 7. So this comes out to be 6.17 into 10 to the power minus 7, which is approximately equal to 620 nanometers. So this would be the threshold wavelength for the metal. Question number 20. The electric field associated with a monochromatic beam becomes 1.2 into 10 to the power 15 times per second. Find the maximum kinetic energy of the photoelectrons when this light falls on a metal surface whose work function is 2 electron volts. Okay. First, let's see what is given in the problem. Okay, now we know that we have to find out maximum kinetic energy, and as per the photoelectric equation, K max is equal to E minus phi. Okay, now phi is the work function which is given as 2 electron volts, and how do we calculate energy of the incident radiation? H nu, like this. So for H nu we need the value of the frequency. Now in this problem, the frequency is not given directly, so we need to calculate frequency. What is given in the problem? It says that the electric field becomes 1.2 into 10 to the power 15 times per second. The variation of electric field happens somewhat like this, like a sine curve. Now if you observe a sine curve, just observe any one period. So in one period, so like if it starts from here till here is one complete period, right? Because this is the time frame in which one cycle is completed. Again, from this point till this point is one complete period, right? So from here till here is one complete period. So from here to here, how many times this wave becomes 0? So how many times the electric field becomes 0? 1 and 2 times. Similarly, when you go from here till here, that is again one period, how many times the wave becomes 0? 1, 2, right? Similarly, again you start from here and go to the next period, which is still here. So how many times this wave, the electric field becomes 0? 1, 2. So that means in one period, it goes through 0 2 times. Correct? So that means if you look at the sine curve, it passes through 0 2 times. So when the curve passes through 0 2 times, that means that the frequency is 1. What is frequency? Frequency is basically how much within a particular time period. So how many times it is happening, right? So this is like 1, this is one cycle, this is one more cycle, this is one more cycle, right? So the frequency is 1, and for corresponding to one frequency, the electric field becomes 0 2 times, right? So this is clear from this graph. So you see, for one period, the graph touches 0 2 times. So that means for one period, your frequency is basically 1, correct? So now, when it passes through 0, 1.2 into 10 to the power 15 times, so what would be the corresponding frequency? The corresponding frequency would be 1 by 2 into 1.2 into 10 to the power 15. So this is equal to 0.6 into 10 to the power 15. So this is the value of frequency. So now that you know the value of frequency, everything became very simple. So now you can calculate K max, which is equal to h nu, that is 6.6 into 10 to the power minus 34 into 0.6 into 10 to the power 15 minus 5, which is given as 2 electron volts. So we will convert it into joules. So we multiply it by 1.6 into 10 to the power minus 19. So this is equal to 3.96 into 10 to the power minus 19 minus 3.2 into 10 to the power minus 19. This is equal to 0.76 into 10 to the power minus 19 joules. So if you want to convert it into electron volt, you can divide it by 1.6 into 10 to the power minus 19, which is equal to 0.475 electron volts. So this much is the maximum kinetic energy of the photoelectrons which are emitted. So I hope you understood this concept of calculating frequency, because this is the most tricky part in this problem. So you are given that how many times the electric field becomes 0. So you need to understand that the electric field becomes 0 2 times corresponding to a frequency 1. So for when frequency is 1, that means only one cycle gets completed. So in one cycle, the electric field becomes 0 2 times. So therefore, when the electric field becomes 0 these many times, then the corresponding frequency will be 1 by 2 multiplied by the given number of times. So that's how we calculate frequency.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.